Let's end this lesson with a few examples of a composition of functions. So we're given an f of x function, we're given a g of x function. We're asked to find f of g of x. First let's, and this is not a required step, let's rewrite this function. I always like to rewrite it. It makes more sense to me if I rewrite it. This is f of g of x. And oftentimes I'll rewrite it because it's more clear to me, seeing it like this, that the g of x function is inside of the f of x function. Okay, I need to put this function into this one. Okay, so how do we then go about doing that? So looking at the f of x function, 3x minus 5, I'm going to write it like this, 3x minus 5. Okay, the open parentheses is where the x was located. Now into the function's x, or replacing the function's x, is going to go this g of x function. So I'm going to put 2x plus 7 into the x here. So it would read 3 times the quantity 2x plus 7 minus 5. And now we just need to simplify this. So this distributes to give 6x plus 21 minus 5. Combine the like terms, we get 6x plus 16. That is f of g of x. Now we do the same thing on this one. If you like, rewrite it first. Now this is the order is reversed is all. It's g of f of x. So in order from left to right, it is g of f of x. So here we can see that the f of x is the function that's on the inside of the g function. Okay, so again, this notation is nice because it allows me to see what is inside of the other function. Okay, so I'm going to start with the g function, which is 2x plus 7. And so where the x was, I am placing the f function inside of it. So I'm going to have 2 times the quantity 3x minus 5 plus 7. I'll do some distributive property to give 6x minus 10 plus the 7. Add the like terms and we get 6x minus 3, and that is g of f of x. Okay, if you would, just real quick before we go on, notice that this answer and this answer, they're different. They're almost always going to be different. Okay, expect that. In section 9.5, we'll talk about the rare case where you have two functions where they are the same, but most of the time they're not going to be the same. Alright, another couple of examples here. F of x is x squared plus 1, g of x is 3x plus 2. We're asked to find f of g of x, which is the same as f of g of x. So I'm placing the g function into the f function. So let's start with the f function as x squared plus 1. Again, the open parentheses representing the x. And into that x, we are going to place the g function. So 3x plus 2 is going into the x, going into these open parentheses here. So we have 3x plus 2 quantity squared plus 1. You cannot just square the 3x, square the 2. That never works. We know that. 3x plus 2 squared has to be written as a product of two binomials. So yes, this is a FOIL problem. FOILs to 9x squared plus 6x plus 6x plus 4, and then the extra plus 1. The like terms make 9x squared plus 12x plus 5. There is f of g of x. Now let's do the same thing on the next slide, except it's not f of g anymore. This is f of f. That's interesting. Here we're asked to compose a function with itself. Rewrite, if you like, this is f of x. Okay, so in other words, we're going to start with the f function, which is, again, x squared plus 1. And into the f function, where the x was, we're going to place the function f itself. We're going to place x squared plus 1. So this again becomes a square binomial, a FOIL type problem. I'll do x squared plus 1 times x squared plus 1 plus the extra 1. I FOIL this to x to the 4th plus x squared plus 1 plus the extra 1. So this is x to the 4th plus 2x squared plus 2. There is f of x. Let's go ahead and skip the next slide and jump to this very last one, as the next one is similar to the previous two slides, and I want to do one that's a little bit different. And what's different about this, you'll notice right away, if you look at the problem, you find f of g. That's part's the same, but it's not of x. It's of 4. Okay, how do we do that? First, let's rewrite it again. I'll follow the same rewrite process I've been doing. I'll just write it from left to right. This is f of g of 4. Now, g of 4 is simply the function value of g at x equals 4. We can do this as kind of like a standalone problem. Okay, g of 4 is 7 minus 4. I'm just simply up here, I'm using the g function. I'm putting 4 in for the x. So 7 minus 4 is 3. Okay. The value of g of 4 is 3. Also, now this problem here rewrites f of, instead of g of 4, g of 4's value is 3. Let's put 3 in here. And now we're asked to find f of 3. And how do we find f of 3? Well, we all know how to do that. We put 3 in for the x in the f function. 2 to the 3rd is computed to be 8. And that's our answer. Notice that the answer to this problem is not a function that has x's in it. The answer to this problem is just a number, because we've evaluated our function at a number. We're going to get a value out, a numerical value out. This last one says g of f of 4. So again, just like I did in the previous problem, I'm going to start inside the parentheses. I'm going to start right here. I'm going to find f of 4. So using the f function right here, we want 2 to the 4th, 16. Okay, rewrite this problem now. It's not g of f of 4 anymore. F of 4 is 16, so it's g of 16. So using the g function, plug 16 into the g function, we have 7 minus 16, negative 9.